PydanticAI is one of the most popular frameworks for building AI agents, and they just announced support for MCP. So if you've been wanting to learn MCP, this is a pretty good place for you to start. We're going to start with a simple PydanticAI agent, and then we're going to add a lot of functionality to it with just a few lines of code using MCP servers. Let's look at how you get started with PydanticAI. We're going to import the agent object and instantiate it by defining which model we want to use. PydanticAI has support for all the major model providers. Here we'll use Claude 3.5 Sonnet. I have found that I get better results with MCP servers using Claude 3.5 Sonnet than with GPT 4.0. Then I'm just going to define a function here. This function is going to run agent.run, and I'm just passing in a user message here. I've just hard-coded hello to kick off the conversation. I store the result, and then I just have a simple loop going where I print the result.data that came back from the agent. I gather new user from the input, and then I run agent.run again. I pass in the new user input, and I also include result.new messages as the message history, and this will keep track of the conversation. Now, I do have this set up as an asynchronous function, not strictly speaking necessary for this simple example, but will be more important once we get into the MCP bits. And this is what it looks like when I run this. And you can see that we are having a conversation here with Claude. And if I ask it a question about a previous input that I gave it, you can see that it knows what I asked it. It does have conversation history. So we wouldn't even really call this an agent. We're just having a chat with a model here, but this is what it takes to get up and running with PydanticAI. The creators of PydanticAI also have a product called Logfire. So I have included Logfire. I have set a Logfire token in a .env. I am loading that in as an environment variable, and then I add this extra parameter here, instrument equals true. And now if I ask a question again, you can see I'm getting a little bit more insight into what's happening. But the real magic happens over here on the web interface. You have the pretty view of the different interactions, and then you can click here on details and see the JSON of what's happening on each of the generations. Now that we have a simple app and some logging set up with PydanticAI, let's look at how we add MCP servers to it. I'm here on modelcontextprotocol.io, and they launched some example servers. And one of probably the biggest bang for the buck that you can get is the fetch MCP server. And I've already run this pip install MCP server fetch. And then it says after installation, you can run it as a script, come into a terminal and run that. You can see now there's a script running. I'm not getting any output or anything, but the server is running and it's awaiting input. So I'm going to kill that. I actually don't need to manually start that. What I need to do instead is tell my Pydantic agent, which is acting as an MCP client, how to start that MCP server. And the way we do that is by importing the MCP server standard IO class from PydanticAI. And then we instantiate a new fetch server by using that class, and we pass to it the commands that are required in order to start the server. So we just saw that the command was Python, and then we need the arguments, which are in a list here, -m, and then MCP server fetch. Once you've defined the server, and here we created a new variable called fetch server, you're going to add an additional parameter to your agent definition called MCP servers. And this is going to be a list of all the servers that you want to equip the agent with. So here we're just going to do one, the fetch server. And so now when we run this, it knows that it has access to a tool that can fetch information from the internet. I am recording this in late March of 2025. It is the middle of the NCAA March Madness tournament. This is obviously information that would not be in the training data for the model. We'll ask for an update on the tournament, and it realizes that it needs to use the fetch tool in order to go find data about that. And we can see here that it did a fetch once, then it did another fetch. Now it's running a third fetch. We'll kick over to Logfire here in a second and see what happened. And this is interesting, it failed. So let's go figure out why it failed. You can see that it ran fetch here with this URL. And the content that we got back from there is a failed to fetch this with a status code of 404. So then it said to itself, let me try another reliable source. It tried again this URL. Let's see if that URL even exists. And it looks like it does. But let's see what happened when it did that. It seems that it got back. So we have some truncated response, but it says that the data that I am seeing appears to be a future schedule. And so then it tried again. So it tried 3 times and then it failed. Let's try something that is perhaps a little bit simpler for it to scrape and parse. And let's just take a look here and see, number 1, Debian Bookworm Live images now reproducible. And let's see what we actually have here. And you can see that is an accurate snapshot of what we're actually seeing on Hacker News right now. All right, so this is pretty cool. I mean, admittedly, that first try didn't work very great, but Fetch is pretty naive in its implementation. There's more complex MCP servers out there if you're doing a lot of scraping or trying to extract structured data from complex JavaScript heavy sites. So you should check those out depending on your use case. But I really like the Fetch MCP server because you really do get a lot of juice for just a little bit of squeeze. I mean, just a few lines of code there, and we all of a sudden could add up-to-the-date knowledge to our model. Also, another thing that we were seeing there is that PydanticAI, it had the ability to try to use the tool, get an error back, realize that it needed to try again. When I said the simple example was not an agent, we were just having a chat with an LLM. This is, I would say, is an agent. I would generally describe an agent as an augmented LLM equipped with tools or knowledge or memory, running in a loop and deciding how to solve problems that you give it on its own. All right, so let's try another MCP server. Another one that the Anthropic team shipped as part of the MCP launch was a Postgres server that gave read-only access to a database. And let's talk about that read-only bit because I think this is a good spot to talk a little bit about how MCP servers work internally. If you've used the APIs to interact with these models before, you may have used function calling. Function calling or tool use is where you define a function for the model to use, and you need to describe the parameters that that function expects, and then often like what the output of that function would be. Most MCP servers are going to be, you could think of them as like tool wrappers or function wrappers. And so the MCP server is going to offer up a list of tools to the model, and the model can call that list of tools and then see what tools it has available to it, see descriptions of when it should use them and how to use them. So the PostgreSQL MCP server is sort of funny because it just has a single tool, and that tool is query. I cloned the full repo, which gave me this directory called servers. And then inside of servers is this directory called source. And inside of here are all of the example MCP servers within this repository. You can see the Postgres one sitting right here. I then ran this Docker build command, and you can see what happens when I run it here, although I've already done this, so it went a little bit faster than the first time that I ran it. And now you can see that I have 2 different ways to run this server. I can either run it using Docker or I can run it using NPX. Let's try the NPX. And so here I have another agent. This is going to be the same as what we just saw with the fetch example. But here I am defining a Postgres server, and I am using this command npx, and then here are the parameters. And the database that I'm using here is a database of movies and shows that are on Netflix. This is a sample database that I found on the internet that has about 8,000 different movies and TV shows. So I have now equipped my Pydantic agent with instructions on how to start the Postgres MCP server. I have included in that a link to my local Netflix database. I have changed the list of MCP servers here to include that Postgres server. And now you can see that when my agent starts up, it's going to say, I can help you run SQL queries on the database. So I'm going to ask it what's in my Postgres database. it is going to run that query tool. And you can see that it contains a comprehensive collection of Netflix content, and it tells me the details. Let's see how many movies Keanu Reeves has been in. And I don't even know if I've spelled his name right there. And it looks like, yes, look at this. So not only did I not spell his name right, but the LLM then corrected the name and corrected me, and then was able to write a SQL query figuring out how many of his movies were in the database. So let's go over here now to Logfire and see what was happening. All right, so here's my initial query. It says it's going to search for movies where he appears in the cast members using I like for case insensitive matching. All right, so then if you can see here, my message, how many movies is Keanu Reeves in? Then you can see the assistant message. It tells me that it's going to search for Keanu Reeves. And then here's the tool calls. It is going to run the function query, and here's the arguments. And it select title type, release year, cast members from Netflix shows, where the cast members I like Keanu Reeves. And then it also, I suppose, kindly included my misspelling as well, just in case I was thinking of somebody else, I guess. So this is pretty awesome. I was able to communicate with the database using natural language. The LLM was able to, on its own, query the database previously in the chat, get an idea for the structure of the database, the fields. It was then able to convert my natural language query into SQL and then get back the results and then summarize those results and return those back to me. That's all just from a few lines of adding an MCP server to an agent. All right, so let's add one more MCP server. This one is going to be a code interpreter from Riza. So this is going to be a safe sandbox where our agent can run code that it writes. All right, so on our previous MCP servers, we were using MCP server standard IO. These were local servers that were running on our machine right next to our script. With Riza, we are going to use a second type of MCP server that PydanticAI supports, which is a remote server. Instead of giving it a command and parameters to run, we're going to give it a URL. To get my URL for Riza, I am going to log into my account. I am going to go to run Riza with MCP, and you'll get a code snippet here of building a super simple PydanticAI integration. Or if you just want the URL, you can copy it right from here, where it says server equals MCP server HTTP. And this is going to give you a URL to a code interpreter MCP remote server with your secret token already on there. So now when we run this, you see it's going to start up again. And now you see that the model says that it has access to Python execution capabilities. So let's think of a problem that would be bad for an LLM, but good for code. Math is typically good for this. So let's ask what's 100 factorial, or as my daughter likes to say, 100. All right, and so you can see here that it ran the execute Python. We got an answer back. This is an enormously large number. And you can see that the LLM wrote some code. That code just imported the math library and then ran math factorial. It got a message back from the tool that was basically a dictionary that said result with then the answer from the operation. And then the assistant took that message and created a response for us. This is just 3 of the thousands of MCP servers that are available. So if you're building anything with agents these days, go play around with MCP. It's astonishing how much functionality you can add to your agents in just a few lines of code.